Hey, hi everyone. I hope everyone is doing well. So, today we are going to discuss a very, I would say, easy to comprehend topic on sharding. I think folks with some industry experience might be able to relate to it much easily compared to folks who are just beginning to pick up system design concepts. So sharding is one form of data partitioning. So before getting into sharding, let's try to maybe understand what do you mean by data partitioning. So data partitioning is essentially done right to improve the performance load, to improve the availability of your data, and it also helps in managing the databases well, right? So there are two forms of data partitioning: horizontal partitioning and vertical partitioning. Horizontal partitioning is where you are actually just uh, looking at, let's say, a table and storing parts of the table in different, let's say, dbs, right? Because the size could be, let's say, huge for one table, right? That's horizontal, and that is what is referred to as sharding. There's another form of partitioning called as vertical partitioning, where you are going to split the table into multiple tables, and essentially what happens in that case is that you are going to split it on the columns. Those are actually called as extension tables, and then you'll have you're going to have same primary key. Uh, the below figure that you're seeing here is an example of horizontal partitioning, which we called as sharding, right? So, straightforward example, that let's say in one table you have three IDs, they're different columns, and then you have split those in such a way that your columns are still intact, and you are saying that I'll keep ID 1 to 2 in one table, ID 3 onwards in another table, right? Now, remember, I think this split can basically be done, and what you have to split can be done in any, like you can use algorithms to do the split on your data set. Like you can use range based splits. For example, you say 1 to 100 in one table, 101 to whatever number in another table, right? Or you can do hash based, right? Hash based would mean like, okay, uh, you have an ID, pass it to a hash function, and then say, okay, whatever output, put that in one table, another output, put that in another table, right? So that's how horizontal partitioning is achieved. One of the, I would say, uh, advantages of the standard advantage is that if, for example, the data that you're going to look into, right? If you know, for example, the IDs that you're going to look into, right? Then you don't touch other tables. So, for example, if you know that you're going to use and search only for IDs 1 and 2, then you're not going to touch this table, right? So, basically, it is allowing you to improve the performance on retrieval of the data, right? Let's look at a real use case, pretty straightforward. An order management system, let's say, is run across different geographies across the globe, such as, let's say, North America, Europe, Southeast Asia, right? In each table, each region will basically, let's say, have the similar schema structure, right? You'll have an order ID, you have a description, date, status, and price. Now imagine if I were to maintain just one table for this, right? Every time, let's say, I'm querying data on Europe, I have to query the entire table, right? And what if I just maintain a separate table for Europe, separate table for Southeast Asia, separate table for America? Right? So this is basically distributing same data, obviously different IDs, your unique identifier, which is a primary key, across different across different tables or databases, right? Wherever those tables reside, right? Um, Pros and cons, I think, straightforward to understand. Nothing fancy. So I think easy to scale out on horizontal partitioning, because you're adding multiple machines. Like you could have this table in one machine and then this one in another machine, right? So you can basically keep on adding machines. It basically helps you to improve the system performance. uh, if I were to do this operation, let's say, compared to, like, if you look at this side, right, the left hand side where the entire table is just sitting in one machine, and if you start, like, looking at the availability, when the number of rows become very high, right, the retrieval time can basically be giving you some sort of lag, right? So availability might be compromised. Availability is always obviously measured in units of time, right? What is the availability in, let's say, 1 second or 1 millisecond or whatever it is, right? And then improving the response time of queries. So here, if I'm querying ID2, uh, it is going to be much faster compared to here, because here you obviously have to go through all the records. Not a very great example, but imagine this table running into millions of records, and then you start looking for this ID2, compared to here where you have kind of, let's say, cut the table into half, right? Let's imagine that, and then you're just querying ID2, right? Query time could be almost doubly fast, right? So that's the response time of queries, and less stagnant data is something that will happen because uh, queries, when you basically, let's say, you use hash based algorithms, right, to partition ID. You built out a hash logic that says that IDs that are being constantly queried on are, let's say, equally distributed, right? So that it doesn't put load on one machine, right? So you basically are not only improving the response time, you're also saying that I don't want a lot of stagnant data, which can happen. Let's say, for example, if you maintain this in a single table, right? If you maintain it in a single table, what can happen is that some of the IDs might be more frequently queried, and some of the IDs might not be frequently queried. So those not frequently queried IDs might sit in the table, but when you're running the query still has to go through the entire, cycle, right? And those stagnant IDs are going to add to the performance of overload, right? So that is the problem. I think some cons, which I would say probably not significant. For example, cost of adding machine is going to increase the infrastructure cost, but that is kind of expected. And where does this happen? Obviously, let's say if you were operating in a single geography, now you plan to expand the business, right? So the cost benefit or the cost drawbacks are nowhere compared to the benefits that you'll have by expanding the business. Tables across shard, I think managing can increase some sort of flexibility. For example, you might have logic, for example, that combines IDs 2 and 3 on some, let's say, output, right? So first you'll have to query this table, then you'll have to query this table, combine the logic, and then deliver the output, right? All the shards might not have the same hit rate, right? So when you distribute these tables across, let's say, different machines, not all the tables fetch. So if one is being more frequently fetched, three is not being fetched, right? This becomes like, some sort of a hot hit, right? So essentially, you can talk about this in system. Where is it helpful in system design interviews is that you might come across, let's say, a design for, as we discussed, right, for Google design, a Google Drive design, right? There, when you say, like, okay, you have your standard systems components, right? uh, there, let's say, you want to, on your data model side, right, you want to talk about scale, where you are saying that I want to also introduce something known as horizontal. So this is more going to be a discussion rather than saying that, okay, like an essential component. There could be questions on you're planning to expand the business on across geographies. How do you do that? This should be like, straightforward approach to handle it. So I hope you found this video useful. I am planning to cover topics on machine learning and system design combined, and then I also plan to cover some of the product related product related case studies, which are going to be mostly around imaginary or fictitious, like, let's say, feature releases, When I say imaginary, like those features are not imaginary, not in the sense that those are not going to be useful, but imaginary from the perspective that those features are still not available on the product that you are using, right? So stay tuned, subscribe to my channel, and watch out this space for more.